Assalamu alaikum. The objective of this lecture is to show you how do we install the Python. Actually, there are three methods to work with the integrated Python. The lightest one is this one, like the file you have on my screen. It is Python. Let's see what are its details. So if I make a right click and look for the properties, it is the file Python 3.7.4 AMD 64. This is for 64-bit machines, 64-bit Windows machine, and it's very light, 25.4. This is to install the basic Python on your PC. So I will make a right click on it. So install now, and that's it. So it will do the installation for me. It will take for a while, and then hopefully we will be able to see it's working. By the time it will go through its installation, I'm also going to place a Python installation guide presentation file for you. So it contains all of the steps. For example, if I go through with that presentation, there are three installation methods. One is with the integrated installation with the Anaconda distribution. Okay, the Anaconda distribution contains an integrated platform for running Python, which is known as Spider. There is an integrated platform like known as Jupyter. Actually, Jupyter integrates the IPython, which is the enhanced interactive Python. It's quite heavy thing, and it integrates many of the scientific libraries in Python. Many of the scientific packages in Python. So if you download the latest version of Anaconda and give it a go to install on your computer, that is the quick solution. Then the other thing that I'm doing in front of you, it is working with the Python integrated development and learning environment. And there is also a famous integration of Python with Visual Studio Code. So these are three methods. Of course, these are the three methods which are familiar to me, and I have tested their working. So if you install with the Anaconda, your file is going to be, the file you will download would be like this: Anaconda 3 something Windows 64. Of course, you have to look for the version compatible with your system. Once you install the Anaconda distribution, then from the start you will find that there are several options to run Python. Anaconda Navigator, Anaconda Prompt, Jupyter Notebook. This is the one in my lectures I'm going to use. It's a kind of interactive notebook type thing where we can also generate some types of notes. And also something I really like is the distribution Spider, which is for scientific Python development environment. So if you successfully install Anaconda, then that is sufficient for all of our work. We can either work in Spider or work with the Jupyter notebook. The other thing that I'm going to do with you is like I said, it is the lightest version of Python, the base version, and depending upon your requirement, you can add libraries to that from the internet, and there are widely available libraries nowadays free of the cost to be integrated, ready to be integrated in your Python, right? And when you are going to install the Python integrated development and learning environment, ideally you will see that there are going to be several modules for that. One is going to be the Python 64-bit Python, and there is going to be the distribution of manuals and module documentation and all that. Let's see what has happened to our new installation. So the setup was successful. That is the message that we have got from computer. So let's close that and let me show you where our Python is. So I go to the start menu. So here we have recently added the ideally Python 3.7 64-bit, and let's look for the whole distribution. So here we have 3 distributions, and if I take you over there, it is 3.7 Python. So here we have all of the packages that has come with this base Python version. So if I run this base Python version, Python, so by making a click on it, it will take us to the running of that. Okay, this is the window that you are going to see. So let's configure that one. Sometimes I prefer that thing so that it is easily visible. Okay, that's nice. So this is the command window. So I can write 2 + 2. So it is going to return here a 4. It comes with its own libraries. For example, if I'm interested to write the sine function, so I have to import the particular library. So in the base version, I have a library named as math. So I import maths library, and let's import all of the functions. So I import all functions. So it means if I write as a comment, that it means import all functions from maths library. So okay, so this has failed. So let me write it again. Let me just write it. Okay, maybe I have to write from math import everything. Yes, this has worked. That was the right way to import. Or if I could recall, I should write import math, and that's it. So I have imported all of the maths function. These math functions include the value of pi, right? So now if I write the sine function, so this is a remarkable feature of this IDLE, that it is going to inform you that these are going to be the arguments of the function, and we have additional information that it returns the sine of x measured in radians. So if I write pi divided by 2, so that will be very much one value will be returned. So if I write cos of, if I define x equal to pi divided by 4, so then I can write cos of x, and square writing is similar to writing the sine function. So the answer is equal to 1. Right. So there are several other inbuilt libraries for Python. For that case, you have to you are referred to the documentation, right? In order to develop a program, we go for developing a new file. So I develop a file. So for example, this is a program file, and in this file my objective is to print a statement. So for example, if I write for I in range 5, so my objective is to print a value of I, right? And with the value of I also print a statement that I like my students to learn Python. Right. So this statement will be printed 5 times. The structure of for loop structure in Python, there is no need to write. Well, the white space is important thing. Tabs are important. Okay. And the moment I'm going to end this indent, the for loop will be completed. Right. So there is no need to write an end statement. Just you have to end. You have to come out of the tab. So that is going to be the end of the statement. End of the loop. So I have to save the program. I can save my program anywhere. So it is in this directory. So let me write that this is the test for loop .py. It is a very much Python file, right? So in order to run this file, you may also notice the path of this file, C users and all that. So in order to run that file, we have the option run over here. So run this module. This is a module. F5 is shortcut for that. So if I run this module, so it will be run like that. Please notice that the index of loop, it runs from 0 to 4. This is something slightly different for my student who are familiar with Fortran. In Fortran, the index runs from 1. Well, we can change that. The thing to be noticed that will appear in the context of vectors, where the index of vectors run from 0 to something, which is similar to C but different to Fortran. Well, this is not the total thing with the Python. The Python's capabilities can be highly enhanced if we add the scientific libraries to that, and the scientific libraries we look for, we can find those libraries over the internet, and there is a comprehensive database for that at scipy.org. The fundamental operations are very similar to as in other programming languages, and with time we will add information to that one. But now let's see how do we build on the libraries. So for that case, I would refer you to visit the scipy.org. So scipy is a Python based ecosystem of open source software for mathematics, science, engineering. So the core packages are these 6 packages. Is the numerical Python library. It helps us to work with very conveniently with vectors and matrices. We have one great library of scientific functions in scipy. The plot library is there in matplotlib. Then the IPython and SumPy for symbolic mathematics and pandas for data structures and analysis. So let's see how do we install that one. So our installation is going to be with this PIP, which is the Python installation package installation for Python. So in order to install PIP, we have to type this command in the path of Python. Let's see where the Python our path is. And in order to work with PIP, we have to first install the package installation for Python. So you have to make a click on PIP. Where is this PIP? Okay, so Python package installer. So how to install that? Installation is here. PIP is the package installer for Python. Okay, so I directly go to installation and it says that get pip.py. Well, our system is Windows. Okay, let's look for the path of Python, where Python is. So it is the path browser. So here we have the Python. Right, our first program named test_for.py. So it is over here. So we have to follow this path. So let me write here. Let's access that one. I write cmd hp. So the path, we are at hp. So application data, then local, then programs, then Python, then slash Python 37. So here we are. If I write here Python, so it will take me to Python. This is another way to run your Python programs and all that. For example, just for the sake of illustration, I write 2 plus 3 here. So it is equal to 5. It is running the same Python. However, from this mode of computation, you will not find the help that was available when we wrote sine of pi in that integrated development and learning environment. So to quit that, I have to write control plus Q. Oh, it's not working. I have to write quit. Yes. So over here I have to write Python installation package. Let me see either I am going right or wrong. Okay, so actually this is the command Python, because pip generally installs with Python ideally. So I'm going to make a click over there. I will paste that path, so it will get pip, install pip and upgrade it, and you will see that type of processing. And after that we are at one command behind the installation of scientific packages. Okay. Successfully installed pip. Now the objective was to install the Python installation packages. So installation via pip. So I have to write this command, Python installation packages. So I copy, it will install numpy, scipy, matplotlib, ipython, Jupyter and all that, sumpy, nose. So it is all in front of you and it will take for a while. And after that you will be able to enjoy the integration of these scientific packages in your Python programs. Meanwhile, let's see what now we have in our presentation. So having installed the pip and then the Python installation package to install your scientific libraries, so you can integrate those, you can import functions from those scientific libraries in your programs. That is kind of economical way of using Python. However, if you have nowadays the disk space is enough for even working with the Anaconda distribution of Python. Okay, so these are few demonstrations, and likewise the Visual Studio Code, it gives you an integration of Python with the command window. So it provides you with its own command window, like here. So the same procedure you have to follow, like you will install the pip and upgrade pip, and then you have to integrate the similar stuff, however writing in the command window provided by the Visual Studio Code. Okay, so that was all in the presentation, and in our Python installation, matplotlib is being installed. So stay tuned to this demonstration. Okay, it has completed working on several things now. Notebook, it is working on notebook 6.03. I generally like this type of installation procedure and working with the software, because that's a kind of common thing when you shift from one platform to the other platform, like working on Windows system and then shifting to the Linux systems. So this type of practice is quite useful. Okay. Well, please enjoy and pardon all of the sound in the background when you are at home. It is impossible to avoid such type of background thing. Okay, it seems we have installed so many things, and you will be overwhelmed when you see what type of libraries you have included in your Python. Okay, let me give you a look for that. So this is the scipy, scipy.org. Let's look for the NumPy library and some of its contents. NumPy. So, well, but where is the right page to look for? Well, to be get started, there are NumPy tutorial, there is scipy lecture notes, but I generally prefer to go to the documentation of that. So here is the documentation, and the first thing is the NumPy documentation. So open that. Well, not here. I always miss where is the right page for looking for that information. So for example, I go to the documentation and then I go to the scipy.org. No, this is okay. For example, if you look for the scipy, so you have the library for basic functions, special functions, interpolation, Fourier transform, signal processing, linear algebra, and here we have statistics and many things, right? Let's explore where is the NumPy library. Let me test this one. Okay, from NumPy tutorial. Okay, well, this is the documentation. I hope this is the right page. No, this is not the right page. Let's go to the numpy.org. No, we have come back to the same thing. Where is that page? Where is that page? Start NumPy manual. Setting up. Not the index by manual. NumPy API reference. Yes. Oh, thank God. Finally, I found the real page. Please note this page. Please note this page. This is the numpy.org development documents reference index.html. So look for the array objects. It contains how to create arrays. Then there are special routines for array creation. We will look for that. We will use some of these things. Then the library of linear algebra functions, right? The library for sorting, searching and counting, and many more things. Therefore learning something very quick and developing your algorithms very quickly and very efficiently, Python is being preferred. And it can also be utilized in an integrated fashion with any of the fundamental languages like C or Fortran, and that is the best combination today. And many institutions around the world, they are working with this type of integrations, and the students are enthusiastically learning Python and integrating that one with the Fortran and C programs, where the computational load is taken care by the Fortran functions. So I invite all of you to eagerly learn Python, and I will give you a kind of a very small tutorial kind of thing and very small introduction to Pythons. And if you get familiar with that, later on you will be able to add things to that very foundation. I'm still waiting for the completeness of that. So it is now running the setup.py to install for mpmath, and it's done. It's a long procedure. Wow, we started from these very steps, but with this hectic practice, I hope that before the next lecture you will be ready to work on Python. Okay, that's it, we have done with that. So now let me develop another program, and that is going to be the final for today's demonstration session. So this is a program. So for example, I write the first line as a comment. So I write program name. This is going to be a test plot dot python, right? So two comment lines. So comments are available. The comment option is available in all programming languages. So for example, now I import library for vectors. So I import NumPy library. Since there are many libraries in NumPy library, so we generally write it NumPy as NP. So and then I will call the specific libraries from NP. It is short for NumPy. Similarly, let me call a library import matplotlib.pyplot as plt. So I have imported a part of library matplotlib. The bigger library contains another library which is pyplot. So I'm calling that whole library, basically the pyplot library within matplotlib main library, and I call that one as a short plt. So instead of writing the whole name, I will be able to call it with plt. So quickly let's generate a vector. So in that case, I will call NumPy dot linear space. This is a function, so it requires a starting point. By the way, let me first save this program so that I will be able to see the help of the library. So I save this file again in the same directory. Well, in these high level programming languages, in this high level programming language and all the other high level programming languages like MATLAB, Scilab, Octave, R, and many others, you have the liberty to save your programs in anywhere in your computer. So this is test plot.python, right? So now linear space, so it starts from 0, and I will complete that one to 5 times pi. Well, pi value is also available from the NumPy library, and I call it that there should be 100 divisions. From 0 to 5 pi, there should be 100 points taken. And now with the NumPy library, I have the facility to call the sine function from NumPy. This sine function will now be applied to the whole vector x. And now I can simply plot, and I can plot it in this fashion, that I will call the library plt. Plt library contain plot function. You can explore that one from the matplotlib website. So I can write xy, and then I can give an attribute, for example blue color, and with the marker like ring, and that's it. So now if I run this program, let's save that program, save and run. So this program will run, and it will generate the plot, numpy has not been found, even though we have run that. Maybe there is a time mismatch between the two. Maybe we have to restart that. Okay, let's do it. So again Python. And now open the file, recent file, well, this was test plot. Okay, and now let's run the module. Okay, so it is still working. The program is being called from this directory. Okay. Oh, I have missed one command. Maybe it will work over here if I write plt show. This is necessary. Okay, that is this is it. This is it. Actually, I should have this command in the main program, but this is integrated. That is the beauty of these high-level programming languages, that if you have missed something in the main program, you can still run the part of program in the command window. You can write the command part of program in the command window. Right, that's it. So for later use, I can also write plt show over here. And now if I run the program from here, it will first ask me to save it and run it. So it will generate the graph. Right. So now please explore the things and other trigonometric functions and their plotting. And I also show you one more thing, that this program was saved in the working directory of Python. So I can also run the program from here just by writing its name. It has been saved in the same directory. So let me run it. Our first program was test4.python. So it executes over here, and if I run the program test plot.python, so it will work over here as well, right? So enjoy Python. Thanks, and hope you will be able to run Python, and you will explore many things from the ecosystem of scientific libraries, which is available at scipy.org. Right? The more you explore, the more you will be amazed, and then it will all be transformed to your own knowledge if you are going to test them in your own programs. So have a very nice experience with Python. Thank you very much.